This talk here is for the people who implement, build, troubleshoot, deploy, monitor, DevOps, SecOps, DevSecOps, SecDevOps. How many of you fit descriptions like that? Great. You come to the right place. We're going to put the fun in cloud security fundamentals. I'm not continuing until I get a few more laughs. Yeah, I could wait here all day. Yeah, well, I could be talking about, I could be putting the mental in AWS Cloud Security Fundamentals. I don't think I'm allowed to give that talk. But here's, because here's what you might be facing, particularly, even as someone who's been using the cloud for a while, but, particularly if you're kind of new to the cloud, you might be looking at the amazingly diverse and broad and deep array of offerings from AWS, 170-something, I think, services now. And this is a screenshot I took of the AWS console. I took that a couple weeks ago. It's already out of date, right? This set is growing all the time. And you'd be well within your rights as somebody who's trying to build security into your applications. You'd be well within your rights to look at a list like this and wonder how you're going to do that task. Right? Look at all of these services. You've probably never even heard of all of these. There are probably some services on this list that you will never use. And the question is, if your organization is using AWS, do you have to learn different security techniques? Do you have to study each of these services in and out in order to understand the particular ways in which you need to secure that service? The good news is no, you don't. Yes, we do have a triple-digit number of services across so many different domains, IoT, networking, databases, storage, machine learning, all of these very, very different domains that you're probably not an expert in all of them. And yet, when it comes to securing what you're doing with these services, there's really only a very small number of fundamental patterns that as a builder in AWS, you're going to see them repeated over and over and over again. So that's what this talk is. We're going to take these three, and I think there are kind of three categories of things that if you understand them sort of from first principles in AWS, you're going to see them everywhere you go in AWS, and you're going to be able to take advantage of them. They're just patterns that repeat over and over again. So that's what we're doing. This is a very builder-focused session. We are going to be high on the practice, low on the theory. You're going to come out of here with some real skills you can use. Hopefully you come out of here and you go back and look at workloads you may already have in the cloud or workloads you're thinking of building in the clouds, and you're going to see these concepts everywhere, and you're going to see applications of these concepts everywhere. So that's what we're going to do. This is kind of a play in 3 acts. We're going to start by talking about permissions, which is, these are all important topics, but that one's the most important. We'll talk about data encryption. And then finally, we'll talk about network security. And like I said, when you go home, you're going to be able to apply what you learn here very directly. We're going to do this from first principles. This is a nuts and bolts session. You're going to be looking at real things here. All right, so let's get started. So the first topic, I said this one was the most important, identity and access management. All right, why did I say it's the most important? Because it's the service in AWS that if you are a customer of AWS, 100% of you are using this service. This is our authentication and authorization service. Now, the WS in AWS stands for web services. And that's, the whole reason why the cloud is so elastic and agile and all of that is, at its core, the cloud is allowing you to provision your infrastructure by calling APIs. Right? Now, if you're going to call APIs, you've got to be somebody and you've got to have permission to call those APIs. And that's true across all of AWS. So as a builder in AWS, you do need to know your way around IAM. And the better you understand it, the more secure your applications are going to be. Although this sounds like kind of a deep domain topic, authentication and authorization, it's very approachable when you sort of break it down to first principles. And so that's what we're going to do here. And then I'll tell you a little bit about how you go get the specifics for each service as you're writing these policies. Okay, but first of all, when you're going to call one of these APIs in AWS, you're going to need to be somebody. You're going to need to be authenticated. Well, there's a number of ways you could be coming into AWS. I'm going to show you give you a flavor of just a couple of them, and whether you are the person at your organization deciding how people get into AWS, or whether somebody's already set this up for you, hopefully this will help you recognize the way in which you're getting to AWS and kind of map it to the rest of this. So you might be coming into AWS as something called an IAM user. An IAM user has it's an identity that is in an AWS account. You may have created one if you showed up to AWS on your first day with a credit card and created an AWS account. You probably went and created an IAM user that has the username and password. Logging into it might look something like that. If you're using our command line interface, you'd have like a different pair of long-term credentials. These are long-term credentials. It's an identity in an account. It's very simple. Works the way you think. If you're in a larger enterprise, though, your source of truth about who's who tends to be in a directory, like, for example, an Active Directory. You'll have users in the Active Directory, you'll have groups, and it could be an Active Directory, it could be G Suite, it could be any number of other things. And an administrator, someone in your organization may have set up kind of a mapping wherein you authenticate your directory and then get mapped into a set of IAM roles in your organization. Now, that's a different word for an identity in AWS. Said IAM users before. These are IAM roles. They pretty much do the same things, except the key difference is the role doesn't have long-term security credentials of its own. You're always coming in from some other identity, and you have temporary security credentials. Now, those of you who are listening to this with your security ears on, you know that temporary credentials are better than long-term credentials. So here, your long-term credentials are, they live in the corporate directory. You get mapped into one of these roles in an AWS account. As a human, the way you're getting into AWS is probably a variant of one or the other of these. Now, not everybody who does something in AWS is a human. Maybe some of you aren't human. I'm not here to judge. But if you are running applications in AWS, like processes in AWS, they probably need to access your AWS resources, your AWS things, your AWS data as well. Like, imagine running a serverless application on Lambda. So you write your function code, it's doing some stuff. It's probably reading data from other services in AWS. And how's it going to do that? It does that with API calls. And those API calls, guess what? They're authenticated and authorized with IAM. So IAM comes into play there as well. I have just a couple of examples of various compute environments. This comes up a lot across AWS. Are various compute environments where you provide some code or some logic or some implementation of something, and it runs on one of these environments or any of many, many more. And these environments will all give you the option of associating an IAM role with the environment. For example, you'll see as you're launching an EC2 instance or creating a Lambda function, you're asked to associate an IAM role with it. That's an identity for your application. The cool thing about that, it's a role, so it uses temporary security credentials that you never have to handle. These compute environments are all really good at taking care of the muck of getting those credentials and delivering them up to the application for you. If you're using one of our SDKs, you almost don't think about this at all because it's just made available to you. The great thing is you're never handling any security credentials. So for our non-human applications that need to access AWS, they get identities too. They're IAM roles. And in fact, I'll even show you what that looks like when you're creating an IAM role, because you will see this screen at some point if you ever go to the console to create a role. And you notice there's actually 4 options across the top. The first option is what I just talked about, roles for our different compute environments, with EC2 and Lambda given as the first choices because they're by far the most common. So you would do this if you had a non-human process that was going to run on some AWS service. You can also get into an IAM role from another AWS account. Hold that thought. We're going to talk about that later. And then the final 2 are for human identities. Human identities that have their credentials, that have their identity sitting either in a web identity or a directory that supports SAML. So these are all the sources from which your identities can be getting into roles. Okay, so you're either a role or a user whenever you're making an API call to AWS. And I just wanted to mention just kind of at a high level what's going on, like how you get authenticated to AWS. So you're coming through one of any number of doors, either in an AWS Services Console or command line interface, an SDK. You're effectively calling these APIs. And what happens, and this is all done for you by the console CLI or SDK, what happens is they take those credentials, be they short-term or long-term credentials, and they sign your request. It's an HMAC signature done with the secret part of the key. The request gets sent to whatever service you're going to call. So up here, we might be calling S3, perhaps to get some data out of a bucket. And S3 receives this request, and it authenticates it. It makes sure that the HMAC signature on it is correct vis-a-vis who claims they're making the call. But of course, that's not enough. So now we know who you are making the call. We know this was a valid call made by whoever's claiming to be making this call. But that's not it. That's not all, right? That was the authentication part. We still need to do the authorization part. We need to know whether this caller actually had permission to read this data from this bucket. And the way that works in AWS is called policies. If you go, again, this is a screen you'll see as well. If you go to the IAM console, down the left rail, policy, you'll see that there's a long, long list of what we call managed policies. These are policies written by AWS for various purposes. The one at the top is administrator access. Guess what that does? That lets you do everything. What these policies are for is they're for common sets of permissions that go together. They're particularly useful for assigning to human beings, because human beings often need complex sets of permissions to carry out human tasks. And if you look at this list, the search bar works very well. If you look at this list, you'll notice that each service has a few managed policies that are defined to help you use both that service and the adjacent services that you need in order for it to work. You'll also notice there are some that are named after job functions, like network administrator, database administrator. If you go and look at the permissions of, for example, database administrator, you'll see that there'll be lots of permissions for the relational database service, RDS, but there will also be a number of permissions in adjacent services, like EC2, that are typically needed in order to do things in RDS. These complex sets of permissions are pretty useful for humans who do complex sets of things. But for your applications, you can get more least privilege than this. If you think about, you write some code for an application, you know exactly what this code is going to do. The APIs that this code is going to call are the APIs that you are calling in the code. And so we can write a permissions policy that is exactly for that. And so I'm going to show you a little bit about how to kind of least privilegize one of these policies, which will also give you a taste of how to read and write these policies. I'll tell you, it's at the fundamental level, it's a really simple matter of string matching. There's a bit of a pattern to it. And I'll tell you, if you want to do a lot of this with me here at reInvent, I'm also giving another talk, SEC209, getting started with AWS identity. We do a lot with policy. You'll come out of that really, really knowing how to interpret policy at a very literal level. But okay, let's write a policy here, and see if we can figure out what it's doing. So a principal and role or user will have associated with it zero or more policies, and each of these policies is going to have one or more statements. These statements all look like this. They all have an effect. Am I allowed to do this thing that I'm talking about, or am I not allowed to do this thing that I'm talking about? So it'll say either allow or deny. It'll say what you are allowed or denied to do. And you'll notice that wildcards are supported. And then resource. What can or can't you do it to? What's the object of this statement? And your API calls are matched against the policies that are attached to you. And if somebody says allow and nobody says denied, it's allowed. Nobody says anything, it's denied. Okay, so what does this mean in English? This means that if I had this policy, if I, for example, attach this policy to the role that my application was going to run on EC2, if I attach that role to that EC2 instance, my application would be able to take all actions in DynamoDB. That's what it means. Now, if you think about that, your application, a typical application, is probably going to be like reading and writing some data. Maybe this is a read-only application. So it'll be reading some data from a table in DynamoDB or NoSQL database. So this policy, you might think this is not quite least privilege, right? For example, DynamoDB has APIs like delete table, and my application is probably not going to be trying to delete a table. And if it does try to delete a table, something's wrong, and I don't want that to work, right? Okay, so I can get a little bit better at this. I can be very specific about the actions. I can look at my code and see what APIs I'm calling in DynamoDB. It turns out I'm calling these APIs, batch get item and get item, or for getting item by key, either in a group or one at a time. And query is, to query against an index. Okay, all right. Been specific about action. This is much better, right? Now I can't delete tables. I didn't need permission to delete tables, so I shouldn't have permission to delete tables. All right? But I can do even better, right? I might have lots of tables in my account, and I know exactly what table my application is written to read, so I'd like to be specific about that as well. And so that's how I do that. I'm specific about the resource. Now, in case you're wondering what that long string is that I just wrote and how I put it together, well, that's called an Amazon resource name, an ARN. You'll see this all across AWS. It's how we it's a fully qualified name to a resource, to a thing in AWS. Now, you can, just to give you a taste of what you can do with the level of flexibility and power these policies give you. This is a different kind of policy. You might be using some things you haven't seen before. You'll notice that I have a condition here. I didn't have one before. It says secrets manager, get secret value. Secrets manager is a great service of ours that, well, it does what you think. It holds your secrets and then lets you control access to them via IAM. So this get secret value is how you reveal the value of the secret. And you'll notice that I have this condition here. And I'll explain in words what the condition does. You'll see that it's talking about the tag on the secrets manager resource. It's saying that tags in AWS are how you attach metadata to items. So if I have a tag on the secret that says what project it belongs to, and then over on the right-hand side of that string equals, it's a variable substitution. The project tag on the principal, they've got to match. Visually, what that's doing over here is a picture like this. A picture like this where I have, let's say I have different projects in my account. I got a red project and a blue project. So let me tag the secrets that are to the red project. I'll tag the secrets for the blue project. I'll tag the role that's supposed to do things with the red project. I'll tag the role to the principal who's I'll tag the role for the project, for the blue project. And each of these should respectively have access to the right secrets. Like red guys shouldn't go in there and get access to the blue secrets. So this thing works. The cool thing about this, so this is called attribute-based access control. The cool thing about this policy is I didn't say anything about red or blue. All I said is that if you have this policy, the projects need to match. You can access secrets that are tagged to the same project as you are. Now you might be wondering, where did I pull all of these policies out of? How do I pull policies out of my hat in order to put on my project? This is how you do it. All of these policies for all of these services all follow the same pattern, and we document it. This is my favorite page of the AWS documentation, bar none. Actions, resources, and condition keys for AWS services. It's a super exciting name, but it is actually, I think, probably the most useful page of our documentation. Down the left rail, you can see that we have a list of every service that we have, and if you go visit that service page, it'll give you a big table with a list of each action that this service supports. For each action, how do you talk about the resource, like what parameters have a resource that we authorize, and for each of those resources, what conditions can you write policies against? And you go and look at, for the service you're using, you want to write a least privilege policy for the application that you're running. You go look at the actions you take, and then figure out how you can tighten it down based on, we'll show you how to write the ARN for the resource and all of that. This is a very useful page of documentation. You'll be consulting it often if you're in the game of least privilege. So all that having been said, we just talked about how to do some nice granular least privilege policy within an AWS account. But if you're using AWS for really almost any kind of enterprise use case, and I'm talking small businesses, I'm talking large businesses, you're probably going to find yourself working with a number of AWS accounts. An AWS account, the best way to think about what that is, it is a container, small c container, for identities and things in AWS. It's a box you can put around a set of resources and identities that go together. So if you're kind of a small business, a startup getting started, you're probably going to want an AWS account, like one for your production environment and one for your test environment and one for your development environment. You're going to want these different environments because you're going to want actually hard walls of isolation between them so they don't get mixed up with each other, so that you can give your developers lots of access to the development environment and not a lot of access to the production environment. At a much larger organization, an organization with many business units and with many different divisions, you might have lots and lots of accounts, hundreds, maybe thousands, each with its own workload. Again, it's a unit of blast radius, containment, and ownership. That's how to think about it. So, in an organization, you're going to tend to have a number of accounts. And so, since it's much easier to draw 4 accounts than 400 accounts, let's draw 4. You might say that you have like the yellow group of users with access to the accounts that contain yellow workloads, the blue or green or whatever color that renders as, with access to the blue accounts, and then maybe they don't know each other, maybe they don't like each other. And then you have this administrator who is highly trusted, who is going to have access to all your environments. And the way you know he's highly trusted is wearing a tie, and we trust people who wear ties, right? Okay. Well, so if you're operating across multiple accounts, you're going to get into a situation like this sooner or later, where you have one account, let's call it account 111, with an identity in it, because remember these IAM roles and users, they too are resources, and they too live in an account. So you have an identity in account 111 needs to access some resource in account 444, like this S3 bucket. An example situation in which that might arise is that S3 bucket might contain sort of business-wide config for your applications, and so they all need to read it across all of these accounts. So cool, I got this. I know how to write a good least privilege policy in IAM. Let's write a policy like this role is going to need permission to talk to this S3 bucket, so let's write a policy for that. Allow S3 get object. That's how you do an ARN for an S3 object, which is the object of S3 get object. Cool. We're done? This gonna work? No, right? Why would I be asking the question if the answer was yes? And also, actually, it shouldn't work, right? If that were to work, then I could sit there in Becky's AWS account and write myself a policy that gives me access to your bucket, and you better believe that's not what we do, right? So, no, this doesn't work, because account 444 owns this bucket, owns this data. They have to have a say in whether these other accounts can get to them. So that's where a concept called resource-based policies comes in. And for many of our services, particularly those like S3 that really anticipate having a lot of cross-account use cases, they offer resource-based policies. S3 will call them bucket policies. Different services will call them, different kinds of names. They're all known as resource-based policies, and all of them are an IAM policy that is attached not to an IAM principal, not to an identity, but to a resource that says who can access this resource. Great, so account 444 does actually intend for account 111 to get access. So they'll write a resource-based policy that's like this. And you'll notice here, this policy, we recognize everything in it. The one thing that's new here is it has a part about principal. That's saying who can take this action. When we attached a policy to a principal, we knew exactly who it was talking about. It was talking about whoever's trying to make the call. For the resource, we have to be specific who it's talking about. This notation, AWS, is how you allow access to another account. So does this mean that the entire account 111 has permission to the bucket? No. What it means very specifically is that I'm trusting whoever's in charge of account 111 to write if whoever's in charge of account 111 allows their callers to get to this bucket, I allow that access as well. So that's specifically what it means. So when this call is authorized, there's 2 accounts involved, 111 making the call and 444 that has the resource. They both need to say yes. So now they both do say yes, and that's why this access is allowed. So this is a pattern you're going to see a lot. Another pattern you're going to see for accessing resources across accounts is this one. See, because not all of our resources support resource-based policies. For example, DynamoDB tables don't. And so this is a pattern you're also going to see in your multi-account environments when you need to start in one account and get to a resource in another account. We've already established that no amount of policy I can put on that role in account 111 is going to get me to that DynamoDB table in account 444, and that's as it should be, right? But I do know that if there were a role in account 444, I could definitely write a good policy to let them get access to the table. Here I'm giving it access to read specific items by key in this table. So if I had that role, I could definitely do this, but that cross-account role, that's not who I am. I'm still in account 111, so how do I get there? Well, this is where, remember we said that IAM roles can be assumed from another account? Well, this is where we're going to do that. So IAM roles, just like S3 buckets, support resource-based policies. In IAM, we call those role trust policies or assume role policy documents. Again, a snippet of IAM. Now, this doesn't say what the role can do. That gray policy says what the role can do. The role can read DynamoDB. This says who can assume this role, who can become this role. You'll notice that the action here is STS, Security Token Service, assume role. And again, there's a principle here saying I'm going to trust account 111. What assume role means, if you look at what STS assume role does, it's an API. STS assume role, when you call it, the result of that request, when it's successful, is a set of temporary credentials. And if you use those temporary credentials to make requests, you are then that role. It allows you to assume that role by giving you some temporary credentials to it. So this role is saying someone from account 111, provided they have permission to do so, can become me, and then, as me, they can go and access that DynamoDB table. So the final part of this is, of course, like I said, that doesn't automatically allow everybody from account 111. Back in account 111, this role, remember, we're not saying anything about DynamoDB because we can't do that, but we can say, I'm going to assume that other role. So the access pattern looks like this. This IAM role assumes the other IAM role, gets back some temporary credentials, and then as that role is accessing the DynamoDB table. If you see assume role policy documents around your accounts that are allowing other accounts, that's the pattern that they have set up. And often you don't need to do this mechanics by yourself. Our SDKs offer various kinds of, they're called role credential providers to allow you to make it easy. So you're not often engaging directly with these mechanics, but that's what's happening. A little bit more on multi-account environments. To manage a multi-account environment, you'll use an AWS service called AWS Organizations. AWS Organizations has a number of really useful integrations around AWS to help you get visibility into one of these multi-account environments. The organization itself is owned by a special account, one that I'm not showing on this picture, called the master account, that they pay the bill for this organization, and they hold a lot of the kind of security and governance levers for the organization. But organizations give you kind of a nice hierarchical view of these accounts. These are organizational units I have up on the screen, and also give you kind of a number of other really useful capabilities here. Remember these green users with access to maybe the accounts in the green OU, these yellow users with access to the yellow OU. So I'm going to create some roles for the blue users, some roles for the yellow users, bring back my highly trusted tie-wearing administrator. And one really nice way a nice sort of facet of organizations, a service that's integrated with organizations that'll let you simply set up something like this is a service called AWS Single Sign-On that allows you to make these mappings. Single sign-on there's a couple of ways to get users into single sign-on. One is you can create them directly in single sign-on, which if you're a smaller organization and you don't have your own separate directory of record, you want to create these identities in AWS once and then map them around. That's a good way to do it. We announced just last week that you can also use Office 365 identities here if you have them in an Azure Active Directory. You can kind of bring those identities into SSO and then map those identities, and then your users are signing in with their Office 365 credentials and being mapped, the blue people into the blue accounts and the yellow people into the yellow accounts and so on. But one really powerful thing, if you are in charge of an AWS organization, at a large organization or at a small organization, one feature you should definitely familiarize yourself with is service control policies. And now that you understand IAM, service control policies are a way to create sort of an outer bound on IAM permissions across this whole organization, or across an organization unit, a part of it. And I'll give you an example of something that's really, really useful to do with service control policies. We get 22 regions around the world, 4 on the way. This number's always going up. I'll make a pretty strong bet that either almost nobody or actually nobody in this room is using all of those regions. You're probably using 1 or 2 or maybe a very small number of regions in AWS. And so you may want to simply prevent anybody from creating any resources in the regions you have no intention of using. If you have no intention of using, say, the Singapore region, you probably want to make it so that if anybody tries to spin up something in Singapore, either accidentally or because they don't understand which regions you use, you probably want that to just get blocked, so you don't have to pay for it. Service control policies offer a great way to do this. Our documentation shows an example of how to do exactly what I just said, with a couple of other examples of common use cases. They look like IAM policies, but they're attached to the organization. They don't grant anybody permission to do anything. Rather, they're expressed mostly in terms of denies. They say what people can't do, and that's authoritative across the whole organization. So if you're in charge of an organization, now that you understand IAM, this is definitely something to look at because it will make your life a lot easier. It will reduce your audit surface. Okay, so now you're pretty good at identity and access management. We're going to move on to sort of our second topic, key management service, data encryption. Because if you're doing anything even halfway interesting in the cloud, there's some data associated with it. And it's probably data you care about and want tight controls over. Key management service is our encryption service that lets you tightly and specifically and visibly control access to that data. Now, this is actually the shortest part of this talk because it's the easiest part. These integrations tend to be pretty simple. So what we're going to talk about here is how to look for those integrations and then kind of what their implications are on your IAM policies, which you now are experts in. So that's what we're going to talk about here. I am going to tell you just a little, since this is a talk about nuts and bolts, and I imagine most of you in this room like to actually understand at a concrete level what's going on. I'm going to explain a little bit about what's going on with our KMS integration with our services. If you don't understand, if you don't follow, it's okay. I'll explain why you don't need to understand this. But the mechanics of KMS is an AWS service. It's got APIs, encrypt and decrypt. These do exactly what you think. They take chunks of 4 kilobytes of data at a time. And you might be thinking like, okay, well, if I'm using KMS to encrypt my data in S3, then my objects, I'm not just storing tweets in S3, I'm storing bigger things than that. They're more than 4 kilobytes long. And so I don't want to keep making a billion round trips to KMS in order to get my data encrypted and decrypted. So the way we encrypt our data in many of our services that hold the data is something called envelope encryption. What that means is that when encrypting the data, we'll go and have KMS generate a data symmetric key that we'll then use locally to chew through all of the data, get it all encrypted, store the encrypted symmetric key along with the data, so then when it's time to decrypt, the only thing we need KMS to decrypt is the symmetric key, so we can then go back and chew through all the data and decrypt it. The reason you didn't need to understand that is because AWS services are doing this for you, so you just need to know how to look for these integrations. However, if you are ever in a situation where you're needing to do these crypto dances, we offer a crypto SDK in AWS that makes this a lot easier. But generally, you don't need to do even that. I'll show you how this integration looks in S3. This pattern repeats around AWS, so if you see it once, you'll be able to look for it and recognize it and use it everywhere. But this is what it looks like when I'm creating an S3 bucket. And you'll notice that as I'm going through the bucket properties, it's asking me about encryption. and I get a couple of choices with encryption. This choice here is, S3, just encrypt my data. It's called SSE S3, server-side encryption S3. S3 encrypts the data with a key controlled by S3. I don't have to think about or worry about anything. That's all S3's problem. The other option is when you want to have a specific key that you use, and the thing about having a specific key is then you can specifically control access to the key, which you may wish to do. The way you would do that is with the SEC KMS option here. Now, if you choose this, you choose which KMS key in your account. If you look at what's in your account, you'll see that there's one that's named S3. This is your default key for S3. It's configured to have permissions so that everybody in your account automatically has permissions to it. You can choose that, or you can choose a KMS key that you want to create that you want to use specifically for this bucket. So let's choose that option. So let's choose a KMS key. KMS keys, they are referred to by GUID. Those are their identifiers in KMS. So let's choose that. Great. S3 is going to, by default, be encrypting all of my data in this bucket. Let's think about what that means from a permissions perspective. Okay, so I have this bucket. It's full of data that I have encrypted with a specific KMS key. And now I have this role, and I want this role to be able to read this encrypted data. Great. I know how to read data from S3. This is how I do it. Allow S3 get object and the correct ARN for the bucket's objects. So what do you think? Think I'm going to be able to read this data? No. You're getting good at answering my questions with no. Right. I can't read why can't I read this data in S3? Yeah, there's another resource involved. Now, it's true that when I called getObject, I wasn't specifically talking about the key. I was talking about the object. But there's another resource sitting there in the wings, and that's the KMS key that was used to encrypt the object. Now, authorization in AWS is done very literally, and that's the way you want it done. So if you're going to access an AWS resource, you better have permission to access that AWS resource. So I have permission to get to the data in the bucket, so that part works, but there's a second part here. In order to decrypt the data, actually give me something that isn't totally useless, I'm going to need permission to the key as well, and right now I don't, right? Because nobody said anything about access to this key, and if nobody says anything about a permission, you don't have it. All right? How do I fix it? Well, I fix it like this, by adding a second part of this policy. So I'm accessing the object. I already had permission to this. Now I'm accessing the key. That's an ARN for a key. You'll see it's GUID over there. And now I have access to this object. So these encryption integrations, they're very simple. Now you know how to look for them. Just turn them on. But just be aware that as you're accessing these items, you will now need permission to both the data and the key in order to be able to get read access. And this gives you sort of 2 points of control. All right. We're at the final part of this, which is network security. Now, it's actually not necessarily true that 100% of you will have a virtual private cloud, your own network in AWS, but probably the vast majority of you will. You know, it's possible to get through AWS without ever managing a network yourself. That would be like an entirely serverless kind of application, API Gateway, Lambda, DynamoDB. In all of those services, no infrastructure is being provisioned specifically for you in a network somewhere. So you don't actually have to manage a network. But VPC does, since it's almost inevitable that at some point you will need some kind of infrastructure running in a network, VPC, Virtual Private Cloud, this is your network that you control and that you control the connectivity into and out of. And those are your security controls at the network level. So networking is a whole domain unto itself. But as far as getting network security right in AWS, there's really only a couple of concepts you need to know. And even if you don't have a deep networking domain or even any networking domain background at all, these are all very approachable, software level, visible concepts that it's easy to understand from first principles. That's what we're going to do here. Okay, so what's a VPC? Stands for virtual private cloud. We also, it's also could think of this as your virtual data center in the cloud, and it lives in one of our regions around the world. If you learn anything about how AWS does global infrastructure, we have these regions all around the world, and for practically all of our services, except for those for which it actually doesn't make sense, a service in a particular region is a completely isolated instance of that service from a service in some other region. So VPC and EC2 are like that, certainly. So when I have a virtual private cloud in AWS, it's going to be in a particular region. Over here, I've chosen arbitrarily our Ireland region as an example, EU West 1. So this is the EU West 1 region. It's divided into multiple availability zones, and these are a great way to build your highly available applications because we show you where the baskets are so you can spread your eggs among multiple baskets. So I want to have a network that kind of spans this in the Ireland region, so that's what I do. I create a VPC, a virtual private cloud. That notation there, 10.0.0.0/16, that's CIDR domain. That's a CIDR notation, classless interdomain routing. Basically means the addresses in the VPC. You choose this. The addresses in the VPC are going to start with 10.0.something.something. Okay, so I've got a network. Inside my network, I'm going to create some subnetworks, some subspaces of that IP address space. You'll notice that some of these subnets are called public, and some of them are called private. I'm going to explain in detail what I mean by those words in just a little while. But a subnet lives in an availability zone, and it gives you somewhere in which you could launch infrastructure. So the private subnet on the lower right-hand side here, would have IP addresses 10.0.50.something. So that's what that notation means. All right, so let's deploy something. Let's deploy some infrastructure into this network. Let's build a really simple web service. And with this web service, my intention, it's going to be fronted by an application load balancer. I'll have only one instance of that, but I create it to span the different availability zones. So when I set it up, I'm telling it about subnets. I have an application load balancer. My external customers, I want my customers from all around the internet to be able to talk to my service, to be able to reach the IP address of this load balancer. These load balancers are backed by a fleet of web servers, EC2 instances, hopefully in an auto-scaling group sitting behind these load balancers. They're running my application code on it, and they'll turn around and maybe get some data out of a relational database that I have that's also in my network. It's a very typical architecture. You've probably seen something like this before. But let's talk about the network security part here. Well, if you understand nothing else, come away from here to understanding nothing else about networking, understand this concept of security groups. Security groups, think of these as firewalls in your network. They specify exactly what kind of connectivity you're expecting. So this sounds like a tool of least privilege, doesn't it, right? Allow the traffic you want, don't allow the traffic you're not expecting. And if you heard me kind of describe what this application does, the infrastructure that I provisioned in here is really in three security groups. And each of these security groups has slightly different rules about what kinds of connectivity I'm expecting. And you do that with security groups. I'll show you what these rules look like. These are screenshots of the VPC console. Everything here, you can also do it via our API. You'll often find yourself doing it with infrastructure as code through CloudFormation. But, at its core, it looks kind of like this. Okay, remember I said my load balancers, they're public-facing, so it's an HTTPS service. So they're going to listen on port 443. And I really do want them to allow everybody in. That's my intention. So that's what 0.0.0/0 means. Now, these security groups, they support, you can have many rules on them, but I'm just going to have one here. Because I don't have rules I don't expect anybody to connect to any other ports on my load balancer, so I don't have a rule for that. And if I don't have a rule for that, I'm not getting that traffic. You'll notice also that there's outbound rules. I'm not going to talk about those here. They're less commonly used. But if you wanted to limit, the outbound connections that could be initiated from here, that's how you would do that. For those of you with a networking background, These are stateful firewalls. And what that means is that they really govern the initiation of this connection. It's really kind of the SYN packet for the TCP connection. It's who can initiate a connection with me, and they're stateful, which means they track the connection, which means once the connection's been allowed, the reply traffic on the connection's automatically allowed. That's why I didn't need to make a rule in the opposite direction, in case you're wondering. Okay, that's my application load balancer. I'm allowing everybody in on port 443 because that was my intention. Now, these web servers that are behind the load balancer, they're certainly expecting traffic to be forwarded by the load balancer, say on port 8443, kind of a private port. But I don't expect that from the internet generally. And in fact, I'm expecting that traffic specifically from the group, from the other security group that was containing the load balancer. So you notice here I'm listening on port 8443. And I'm allowing not an IP address range, but another security group. So this is kind of allowing the load balancers by reference, right? If I look at now the databases are in a separate security group. That rule looks similar. It's allowing the security group with the web servers, because I'm expecting queries from those. But this one's on port 3306, the MySQL/Aurora port. So that's how this works. You build your application. For anything that has an IAM role associated with it, you write a nice least privilege IAM role that does allows exactly the actions that your application is going to take, and then you think about where the packets are going to flow on what ports, and you write security group rules that allow exactly that and nothing more. Now, in practice, I made a very simple example here. In practice, you may have other sources of connections to this database, so you'd have other rules for that. For my web servers, if you needed operators to have SSH access to it, maybe you have a second rule about port 22 with specific IP addresses that are allowed to connect into that, or maybe a bastion or something like that. But, it's fundamental. This is how you do network security in AWS. If you get that, you're building secure networks in AWS. That's really it. But there's a second concept that, in an enterprise environment, you'll probably encounter this, and it's worth knowing too, because it's a second layer of security that you can apply, and it's routing. And again, routing sounds like a hairy networking topic, and it can be, but in the world of AWS, again, it's straightforward, it's visible, it's really comprehensible to anybody. You just break it down to first principles here. So I promised I would explain what public and private subnets meant. Let's look at this subnet that I'm calling the private subnet. And you'll notice the kinds of things I put in this private subnet are actually what you would think of as private. I don't want the world connecting to my web servers. I don't want the world connecting to my database. I do want the world connecting to the load balancers. So you can kind of understand sort of on a conceptual level why I put each of these where I did. But very specifically in AWS, what we call a private subnet is a subnet that has no direct route to the internet. So subnets in VPC have route tables. This is the route table for my private subnet. This is the most simple route table that exists. It's got the one route that every VPC route table has by default. That route says that the destination 10.0.0.0/16, so that's packets that are destined for my VPC, I'm going to route them local to my VPC. I have no routes for any other kind of packet, so if a packet is trying to leave the VPC, it will have no route, it will have nowhere to go, it gets black holed. As far as the subnet that is concerned, everything that happens in this VPC stays in this VPC. Right, and that's kind of what I want here. I don't need these instances in this database communicating with the outside world. Now, if I go look at the public subnet, though those load balancers, they're going to have publicly routable IP addresses on them, which means they're going to need a route to and from the internet. So that's done by an abstraction called an internet gateway that you would attach to your VPC. The internet gateway isn't a router of any kind, isn't a single point of failure of any kind. It's really just an abstraction that you attach to your VPC to denote that you're going to be routing traffic to the internet. And in your route table, you notice I now have a second route here, 0/0. It's what you would call a default route. It matches everything that doesn't match a more specific route. So if a packet's trying to leave the VPC, I say, okay, I'm going to send it to the internet gateway so that it can make its way to the internet, so that the internet can reach my load balancers, and my load balancers can send replies to the internet. So that's how this works. Now, there's actually an intermediate option in here. I'm not going to go into detail about it, but I'll just mention it, so if you see it in your environment, you'll know what it is. it's often the case that those private subnets, you don't want things in that private subnet to be individually have publicly routable IP addresses. You don't want anybody connecting to them. Sometimes you want them initiating connections out to the world. Like if you think about like access to a Yum repo in order to download software, that kind of thing. The option for that is something called, for those of you with a networking background, you know that the technique for that is called network address translation, NAT. So we offer a NAT gateway. So if you are looking at a private subnet and you see a 0/0 route to a NAT gateway, that's what's going on. Your infrastructure in there cannot be reached from the internet, but it can send outbound traffic and get replies. Okay, so let's stick with this private subnet idea for a little while. And if you use AWS and you look at specifically at the endpoints that you talk to AWS services at, you'll notice that maybe even most AWS services that you're talking to are not in your VPC, right? If I take CloudWatch Logs, a great service for aggregating and analyzing and troubleshooting logs, I take its DNS name, logs.eus1.amazonaws.com. I resolve that DNS name, and that is definitely not an IP address in my VPC. But CloudWatch Logs and many other services are very useful. For example, a very useful thing you can do if you're running an application on your EC2 instance, you can run our CloudWatch Logs agent on your EC2 instance, and with a very simple config file, you can just tell it the logs are at var log whatever, and the agent will just send your data right off into CloudWatch Logs, so your logs will be in one place. There's an encryption integration. You'll be able to use great tools like CloudWatch Logs Insight. The only problem is this service is not in your VPC. By the way, one way to think of these services that aren't in your VPC is they were serverless before serverless was serverless. Like the thing about these services is they're not provisioning infrastructure in your network, and that's why they don't appear in your network. But remember, my private subnets had no route, to that 54 dot address. So how are my agents going to work? The solution to this is something called a VPC endpoint. Many of our services offer one. The VPC endpoint serves a couple of purposes from a security standpoint. It's a really great security tool. One reason why it's a great security tool is it lets you do connectivity least privilege here. So a VPC endpoint lets me plant CloudWatch Logs at IP addresses in my VPC. So now I do have a route to CloudWatch Logs. And in fact, it does some things with the DNS name so that logs.eus1.amazonaws will resolve to these addresses in your VPC. So now your CloudWatch Logs agents can send traffic to CloudWatch Logs. It goes through the VPC endpoint, so the route's working fine, and get into CloudWatch Logs, and you get all the benefits of centralized logging in the cloud. But there's actually a couple more things that you can do with VPC endpoints. A bunch of our VPC endpoint services, such as CloudWatch Logs, support something called VPC endpoint policy. Now, we looked at IAM policies before, and this is indeed an IAM policy, but it's not attached to an identity, and it's not attached to a resource, and it's not attached to an organization. This time, it's attached to a network, a VPC. This is kind of how you use your network as a security perimeter. Now, this policy that you're looking at does not grant access to anybody to do anything. Again, it's an outer bound on what can occur what kinds of calls to CloudWatch Logs can be initiated from this VPC through this VPC endpoint. I'll kind of translate for you what this policy means. It's a new condition that you haven't seen yet here, principal org ID. What this policy asserts is it says, okay, anybody using CloudWatch Logs from within this network, the caller better be from my organization. Actually, we just launched last week. You could even talk about require that they be from a specific organizational unit. I'm not doing it here, but I could have written a very specific policy. If I know exactly what CloudWatch log groups I expect logs to go to, I could have been specific about that. Again, this policy doesn't let anybody do anything. It takes away privilege. It creates an outer bound. It creates a guardrail. That's not all you can do with these. Because the VPC endpoint is part of the network path, it actually becomes something you could refer to in your authorization policy. So imagine this role here. This role here, I want to give it access to S3 via a VPC endpoint, and And of course I could put a VPC endpoint policy on that VPC, we looked at that before. But if I attach a policy like this to this role, you'll notice I added okay, so this is giving me S3 get object to the things in this bucket, but I'm asserting that if this role is accessing this S3 bucket, the network path better include the VPC, this particular VPC endpoint. Now, if you think about what that means, that effectively is locking my role inside this network. If somebody went and tried to, launch this role on an EC2 instance in some other network, it wouldn't work because this condition wouldn't be satisfied. So this means that this role can access this data in S3, but I have a particular network I expect it to exist in, and it better exist in there. And in fact, you can use this condition down here on identity policies, and anything you can do in identity policies, you can also do in the resource-based policies. So if we write this on the S3 bucket, here I'm writing it as a deny policy. This is a way to make a nice kind of bucket-wide assertion of who can get into this bucket. And I've said, okay, if they're going to be accessing this bucket, I'm a bucket, I'll let people access me, except I'm going to deny it unless they're coming through a network path, a specific network path that I'm expecting, and if they're a specific from a specific organization that I'm expecting. This is my colors, my networks on this bucket. So you really can do a lot of powerful things with these network path controls. So it's worth looking at, if you're using VPC endpoints in your environment, you'll now kind of understand how all of this is put together. This kind of brings us to the end here. All right, so hopefully you've come away with a kind of a nuts and bolts, a fundamental, a foundational level understanding of these three, I think, most important patterns that repeat all across AWS. So we talked about permissions management, we talked about who you are when you're talking to AWS and how you get permission to do the things that you need to do. Talked a little bit about encryption. Basically, if you're going to be storing data in an AWS service, look for that integration, and you can turn it on. You understand what to do with the policy if you have a KMS key involved. And finally, when you're going to be provisioning infrastructure in your network, how you take good control of the security levers available to you in that network. You're not done. You guys are builders. You know how to learn things. You learn things by doing. So hopefully you're going home here armed with sort of the fundamentals so that you can go and recognize these patterns in your environment. I would say go home and build something. Try to make use of these patterns, experiment with them, get your hands on them. They repeat all around AWS, so you learn them once and you use them everywhere in the cloud. Thank you so much for being here. Have a great time at the rest of reInvent. Thank you so much.